Okay, I want to talk quickly about the sum of exterior angles of a polygon. I'm hesitant to give you the whole proof of this because I don't want it to be overcomplicated. And I really don't want to give you just a quick and tell you example because I think it'd be too simplified. I want to give a little bit of idea where it comes from. So let's start here. Let's start with this idea. If we have a triangle, okay, they have three interior angles. 1, 2, 3. Now we can create exterior angles, and what an exterior angle does, it just extends. If you extend one of the sides to be straight out from here, this now is an exterior angle. Okay, and it could have been this other one. It could have been this one over here too. Oops, let's use a different color. It could have been, for example, this angle. But if you think about it, those two angles are called vertical angles. We had learned about this before. And because these are vertical angles, they're equal. So an exterior angle would be equal to each other, these two. So let's just look at one of the exterior angles here. Actually, do this way. Okay, there's an exterior angle. So I can draw three exterior angles in a triangle. I want to use the same color here. And let's just go. So I have three exterior angles. And the question is, what do those exterior angles add to? What's the sum? Okay, well, I'm going to do a quick, just numerical example here. Let's say that this is a 60-degree angle. And these have to add to 180, so this might not be perfect. Let's go, this is a 60. This is a 50, which adds to 110, which means this would have to be a 70. I don't think it's a scale, but that works. So hopefully you agree that these would all be, that would add to 180, which means those could be good examples. So our exterior angles, because they're a linear pair and they're supplementary, again, past vocab ideas, these two as in the 60 here and this exterior angle have to add to 180. So that means this one would have to be 110. 120, I mean. If you know how to do math, it's 120. That adds a 180. This would have to be 130, same idea, have to add to 180. And this one would have to be 110. Now if you add all these up, 120 plus 130 plus 110, that equals 360 degrees. Exterior angles add to 360 degrees. Okay? If you think about the same idea in maybe an equilateral triangle, let's take an equilateral triangle. $60, 60, 60. Let's make some exterior angles off of here. 120, because they add to 180. 120, 120. That equals 360. When you add all three of those 120s together, it's 360. Okay, so what, Mr. Tating? Exterior angles on triangles, they add to 360. You can keep on doing this over and over again, and hopefully you would keep on seeing that they would add to 360. Okay. What if it's a quadrilateral? We know that quadrilaterals' interior angles add to 360. So let's try to do, you know what, I can start with a nice easy square, but let's go with a trapezoid. Ooh, let's go with an isosceles trapezoid. That's close to isosceles. We'll call these two sides equal length. Now what's interesting about isosceles trapezoids, and you can just believe me here, with isosceles trapezoids, these base angles are equal, and so are these base angles are equal. They're different than the other base angles, but they're equal. So, and they have to add to 180. These two have to add to 180. So these two would have to add to 180. So Let's say that this is 100, let's go 100 degrees. 100 degrees, and that's 80. And this would have to be 100 degrees and 80. And if you add those four up, that adds to 360 on the inside. So then the question is, what do the exterior angles add to? Well, I'm going to extend a few of these. Look at this angle. Okay, well, same idea. These two angles have to add to 180. So that means this exterior angle here is 100. This one over here, up on the top, that has to be 80. To the right, that's also 80. Add to 180. And this one is 100. So now we have these three angles. You add all those up, that also equals 360. It's kind of weird. It's the same as a triangle. What if I did a square? I think before I even finish drawing this square and labeling and explaining it, you get the idea. These are all 90s, which means that every exterior angle is going to be 90. 4 times 90 degrees, 360 again. So we can keep on doing this. I'll do one more example. Let's take a regular pentagon. So let's take a regular, I want to keep my drawing here. So, what do we know about a pentagon? Well, they all the interior angles add to 540. So if we take 540, divide by 5, I believe that is 108. So that tells me that if this is a regular pentagon, each interior angle has to be 108 degrees. So then if I draw a exterior angle here, that'd be 180 minus 108, which is 72. So that means every one of these exterior angles, no matter how I drew it, would have to be 72 degrees. So there'd be 5 times 72 degrees, 360 degrees. So yes, the sum of all exterior angles are always 360 degrees. Kind of weird. Okay, these examples use a lot of different, some of this is a review, a lot of it's review, some of it's what we just learned on the exterior angles, but I just want to kind of go through how you would solve each one of these. So for like 10, 11, and 12, those are all interior angles, sums. And on the last video, we learned that if you take the number of sides minus 2 times 180, that gives you how many degrees are in each shape. This number 10, that's a quadrilateral. So 4 sides, that's 360 degrees total. So if you just take 360 minus 53 minus 85 minus 120, you'll get y. This is a pentagon, right? 1, 2, 3, 4, 5. So this has 5 sides. So you can plug a 5 in here. 5 minus 2 times 180, that's 540. So again, you do 540 minus all of those. And you can use the same thing here. This is a 7-sided, a heptagon. 1, 2, 3, 4, 5, 6, 7. So you would substitute a 7. You go 180 times 7 minus 2. Get what the total sum is. Subtract out all these, get x. Okay. On the bottom here, you're going to do the same thing, but they want you to use algebra for like number 13. So this, again, is 1, 2, 3, 4, 5, 6, 7, 8 sides. So what you would do is you would use our interior sum formula with 8 to get your total sum. And then you're going to have to do a formula n plus 161 plus these. I mean, really, you could just add up all the numbers, add up all the n's, and that's going to equal whatever your sum is for the octagon. Now this one, I think you can actually use, and they want you to get all these sides, but you can actually use the exterior one. In fact, that's what I would use anyways. If you look at the interiors, x, y, and z doesn't help you at all. But if you look at the exteriors, they're all in terms of w. So we can do w, ooh, let's use a different pen there. So we can do w plus w minus 13 plus w plus 10 equals 360, because all exteriors should add to 360. Solve that for w, substitute it back in to get these angles, and you can find x, y, and z also. And on this 15, it's the same thing. These are all exterior angles. Add all 4 of those to 360, find out what x equals.